Hello React Native developers, I hope you are well. William here, recording from beautiful Zurich, Switzerland. Every time we tackle a Can It Be Done in React Native episode, it's a bit like solving a puzzle. We have our pieces, which are the primitives we know and love from React Native. So we have our pan gesture handler piece, we have our reanimated piece, we have our SVG piece, and then it's about putting all these different pieces together in a way that can enable us to achieve the desired user experience and to build it at 60 FPS, even on low-grade Android devices. In the next week episode of Can It Be Done in React Native, it's one I'm very excited about. We need a primitive that we don't have yet in our toolbox. So I thought I would introduce it to you now, and then next week, Can It Be Done in React Native, we can use this primitive with peace of mind because we know already how it works. And this primitive is the Angular gradient. So in React Native, we can do linear gradients, such as this one, no problem. Using SVG, we can also build radial gradient, such as this one. And next week, we need to animate some rings, which go from one color to the other. Therefore, we need to have an Angular gradient. So here the color interpolation is done through the circle and not through a line. And how would we do this in React Native? There are two ways we can achieve this effect in React Native. The first way is using an OpenGL shader, and the second way is using an image mask with a mask element. Why would we use an OpenGL shader to build such a gradient? I think because it's fun and because we can use this technique to build way more complex things than such a gradient. And why would we use a mask element to build such a gradient? Because it's very, very practical. So in this video, I would like to show you the OpenGL shader, and in the next video, I'm going to show you the mask element technique. So here I've built such an Angular gradient as the one we're trying to achieve. I hope that you can still see the contrast between the starting and ending color. Because of the video compression, probably the colors are not so sharp anymore. And the way I built such a gradient was super naive. I used an OpenGL view. I used processing.js, which it's an old library. Now it's known as p5.js. And Expo provides an integration between the OpenGL view from Expo and this library. In fact, if you're interested in the topic of OpenGL, I recommend you check out the Expo YouTube channel. Evan Bacon makes amazing videos on this topic. So you have using WebGL in React Native, part 1, 3D graphics in React Native with 3.js. So Expo also provides an integration between 3.js and 3.js and the GL Expo. I haven't tried it yet, but I'm really looking forward to try it. In my case, I used the processing.js integration, which is a bit too bad because processing.js is an old library. Now it's p5.js. It seems maybe that it's harder to integrate between p5 and the OpenGL view, but anyways, I think also with 3.js you can do like a lot of cool stuff, and I think Evan Bacon wrote it in TypeScript, so you might also get some types out of the box. I haven't played with it yet, but hopefully in the near future. But definitely check out this channel if you want to learn more about this topic. And so I just basically built the shape, the Angular gradient using processing.js. So I start a shape of triangles, and then so I'm building the circle as a series of triangles, and I'm using 75 triangles per circles. So I can calculate. So the first position is the center of the circle, and then I calculate x1 and x2 by converting. So we divide 2 pi by the number of samples we need. Then we get the x1, x2 position. We know how to convert from these polar coordinates to the Canva coordinates. And then we interpolate the color from the start, from the end to the start to find which color we need to use. And we draw the triangle here. And then at the end, we invoke no loop to say, okay, stop. We need only to render this image once. So this works, but I mean, it's a massive computation. Even though we do it only once, we have to do it for each circle. And this computation is done sequentially, right? So we calculate each triangle one at a time. So that actually is going to require us, even if we only do it once, to execute quite some JavaScript code from the start. And in fact, I tweeted the example on Twitter, and you see here the frame rate and on the UI and JS thread, and you see at the beginning 150, okay, 600, but 60. But you see that at the beginning there is really a big cost of building these circles. So I thought we would do an OpenGL shader instead to build such Angular gradient. So a shader is a program that is compiled and executed by the GPU. So we, for each pixel, instead of sequentially calculating the with triangles, calculating the color of each pieces of the circle, we, for each pixel, execute a program in parallel that will determine its color. So it's going to be transparent if it's outside the shape of the circle, and depending on the angle of its polar coordinate, we're going to interpolate the color. And one way, so there are a couple of ways we can execute shaders in React Native. The first one would be to do it from the GL view, but it's a lot of boilerplate code, and there are a lot of libraries that can help us with this boilerplate. Tree.js is one of them, actually. I love to use GL React. It integrates very nicely with Expo. And I really just love that this API has been designed with React in mind. And you can do composition through elements. I just find it to be super elegant API. And I think, yeah, the design of this library is really, really good. So here you see I have the Hello World example, and I'm just going to paste it here. So here we don't have surface from GL React, but it's going to be Expo, what was it? So GL React Expo. So we have our shader here, which is this program that will be executed on the GPU. And then here we have our component, which I can maybe transform into a functional component. And the size, we're going to do the size as defined in our constants. Let's have a look. Okay, so I need to use through the style property. All right, so that looks good. Now we need to write our shader so that first it implements the shape of a circle and then the Angular gradient. And I think we are going to start with drawing the shape, and then we'll do the gradient. And so to draw the shape, so you see here we receive UV as a vector, as parameter, so which are the position of the pixel in the canvas, and the position goes from 0 to 1 on the X and Y axis. And we have the uniform property where we can pass some variables as parameter to the fragment, so to the shader. So we can use, I think, uniform, and I'm going to pass the size as parameter. So it's going to be, I think here we receive the ring as property. So ring is, so let me just write this down, Angular gradient props. Ring is a set of interface, is a set of properties including the start and end color, the background color, some value here we don't need, and its size. So we have 3 different sizes, so we're going to use ring.size, and we can pass the start and end color as parameter. So here my colors are as strings. We need to convert it into an array, and an array where the value goes from 0 to 1 and not 0 to 255. So we're going to use color for that. So ring start color, and then we can call the array method on it, and then we need to convert each value to a value that goes from 0 to 1. So we can just do v divided by 255. That looks good, I think. And same for end. So now we have the size, we can draw the shape. So we can calculate, so we have the, okay, I need to declare these 3 variables now that are available. So I have uniform, and it's a vector of 3 values, start, end. And then we have uniform, and it's a float of the size, ring size. So so now we can calculate the distance of the pixel from the center of the canvas. If it's higher than size, we don't display a color. If yes, we display a color. So here we're gonna calculate the distance from the center of the screen. So we're gonna use distance of the position. So this is the position of the current pixel, and the center is, because we go from 0 to 1 in every axis, is 0, 5. And by the way, this here, it's a value in pixel, needs to go from 0 to 1, and it's the middle of the canvas, so it's 0, 5. And I'm gonna adjust the size of the canvas to be of the size of the ring. So ring size, and so what we can do now is that if the distance is greater than size, we don't display anything. We display a transparent pixel. If not, we display this pixel, which, so at the end, right, GL frag color is a special variable that is gonna give you the size of the color of the pixel. Ring identifier has been so that should be good. So is it uniforms? All right, that looks good. So here I'm getting some warnings because I'm not using the start and end uniform yet, but we did manage to draw our circles. Now let's do the creation color. So we are gonna need to calculate the, so we're gonna take the position and transform it into the, so the position in the canvas coordinate, we need to transform it into a Cartesian coordinate, and then using a tan, we're gonna get the value of the angle, and we're gonna use the value of the angle to finally interpolate the color. So we're gonna create, it's a vector 2, so we're gonna call it position, and it's the UV minus the center. So maybe I can just create one here. Now we can get the value, so I can call it A, which is a tan of position Y on position X, and So if we go to the A10 documentation, here it is. We see that if we use the second overload, which we are, the value goes from minus pi divided by 2 to pi divided by 2. And we need the value to go from 0 to 1. So that gives us A equals, so it goes from minus pi divided by 2, pi divided by 2. So we do, if we do A divide, so if we do 2A divided by pi, we go from minus 1 to 1. Then if we add 1 to each, we have 2A divided by pi, that goes from 1 to 2, plus 1, no, 0 to 2, sorry. And so finally, we need to divide everything by 2. So we have A divided by pi plus 0.5 goes from 0 to 1. So this is what we're going to use to interpolate the color. So we can create and to interpolate the color, we can use the mix function. So I'm going to have a new color here, and we're going to mix the start. So the end, start, and the progress, which is this variable here. Up. And so if the distance is below the radius, we're going to display this particular color. Okay, so here we forgot to add the opacity to the color, so I can do vector 4 and add an opacity of 1. I'm actually surprised this one works, should be 0.0. Looks good. Let's have a look. All right, so here it is. We have our beautiful angular gradient done in OpenGL. So this might be a bit overkill just to implement an angular gradient, but I think it's an incredible, powerful tool we can use to build maybe way more complex thing than just an angular gradient. And it's really based on this premise that executing in parallel for each pixels on the GPU such a program. And we use React.jl that to interface between ExpoGL and our React code. And here you can do, so you have the surface component, which is a dependency with ExpoGL, but then you have these nodes, which you can compose like you would do with a regular React component, which I find to be very cool. And you can do all sorts of cool things. And it makes all the boilerplate for compiling, executing the shader, creating all the buffers that needs to be created. So if you were to do all this work manually, that would be actually quite a lot of work. There is this resource called the Book of Shaders if you want to learn more about this topic, which I find to be an incredible resource. It's super well done. So that was part 1. In part 2, I'm going to show you how to implement the exact same Angular gradient, but using the mask element from React Native. So I will see you in the next video. And in the meantime, if you're interested to learn the fundamentals of gestures and animations in React Native, check out my online course at startreactnative.dev. My goal with this course is to provide you with all the tools and knowledge necessary in order to build incredible user experiences that run at 60 FPS even on low-grade Android devices. So if you are interested to learn the fundamentals, please check it out at startreactnative.dev.